three different costs: the material cost, the capital cost, and the labor cost. Suppose the material cost per part, total material cost plus the cost of the number of parts per unit part, and the labor cost, for example, $10 an hour, and you are producing 10 parts an hour. So it would total cost one dollar. Okay, and then you add this. So you will see, you can find out the cost of the casting at a large scale. So this will be the homework problem which I'm gonna assign you this week. Okay, let's do the next topic, which is our forging deformation process. So I think you have the access to to these slides, the deformation process. Everything is happening inside the plastic region. Plastic stress strain curve. Okay, stress strain curve. Everything is happening after the yielding point. So here and here. The the law which governs this uh, region is stress equals to K times epsilon to the power n. And if this temperature, we will study about this soon. So let me show you different types of the deformation processes. So you will study four different types of deformation processes: forging, wire drawing, extrusion and rolling in this class. Some of the machines which you will see when you find such a company which is performing this is, I believe it's a old manufacturing process where the hammer which is run by the electrical motor is forging the material. And you will study, I want to just allude it to you. So suppose this is my forging piece, I want to forge it. So what will happen? So the ram, it strikes this metal, and this is the table. So it comes down with a force, and this is known as open die forging. There are two types of forging: open die forging. Keep in mind this one thing I want to allude it to you. The center line is very important because material, after you hit it very hard, material changes its dimensions. The height, the final height is smaller than initial height. Agreed? Initial height is larger. And but I want to tell you one thing. One equation is going to solve a lot of problem. Volume is constant. Volume is constant. So you will use that consistency in volume, area, initial, length, initial, area, final, later down the stage. So we will understand this analysis. Okay. So this is the open die forge. The forging force comes down and forges the material into desired shape. And sometime we have closed die operation, which we will see soon. Okay, wire drawing process. This machine is a very large machine, and these are some uh, motors which are pulling the wire. and it is also cooling down as well. Extrusion process. There is a backward force, extrusion force. They're a little bit different, you see. So if the die, suppose if you have maybe maybe like this, initial diameter is, you are, if you are pushing it, we call it extrusion. This is now extrusion. Behind this material, this is coming out of the die. This is my die, okay? And this is my, the diameter, it reduces or it changes the shape of the die. Sometimes it's uh, like a railing. You see, this is all extruded manufacturing process, because it passes through the die and you have a push behind. You keep pushing the metal through the die, it adopts the shape of the. Similarly, curtain railings, they are all extrusion process. And the wire drawing, the process, the die is the same. You pull it, drawing force. You see, these are the motors, which are actually, somehow it's not very clear here, but you are pulling the metal outside the die. You will study it later, but it's just explanation. Rolling process. You see big rollers. And I mentioned earlier that in the rolling process, it's the same thing. Like if you see, look over here, if I have a roller like this and roller like this. So it's like a drawing process, but in a very sophisticated manner. You have two rollers, the metal passes, and the rollers keep on reducing the diameter. We have to change the shape plastically, deforming it in a new shape. Some rollers, they have, you will see some rollers, they have different type of cross section. So if you have a different cross section here, so the material, like a long cylindrical pipe, they are being rolled slowly. This changes, this curve starts becoming smaller and smaller and smaller, and at the end it adopts a cylindrical shape, and it is welded at the end. You understood this four processes: forging, extrusion, drawing, rolling. And rolling is almost same, not very much same, but the process is to deform it plastically. And the governing law is, I mentioned, K epsilon to the power n. I want to show you the analysis. How do you analyze in the forging process? The process to make parts with material removal. Without material removal is the deformation process. Deformation occurs on parts with length to diameter ratio approximately the same, the high volume. So examples of products, for example, you can deform connecting rods are deformation processes, wire drawing, bars, windows frames, they are extruded. The railroad engine connecting rod, very big connecting rod, they are forged into the big hammer process. Forging force comes and adopts the shapes. Typical product dimensions: small to large. Small examples: small forging processes, coins, surgical wires. Large: power plant turbine shafts, aircraft landing gear. They are very large, but they are still deformation processes. The landing gear of aircraft. This is army helicopter, the plane. So landing gear, they are forced. When you force the material, it creates more strength, more power to withstand the stresses. They are internal grain structures, materials deformed. The tensile stress equals to the K times epsilon, and work hardening, grain refinement, grain orientation. These are plasticity, friction. You will study at your own time these slides. So plasticity analysis. So the platons, they come into contact with the forging. This is my forging material. We want to reduce the height from here to maybe a new height. The forging forces. We call this as a plane as strain, plane stresses. We assume that this area does not deform. For example, this area does not deform over here. So this area does not deform. Only the height reduces. We assume that's why we have a restricted one plane, plane strain. And the governing law is this one. I think I went over the review section. We studied about the plastic domain, maximum shear stress is given by this uh, Tresca yield criteria, sigma flow, and the material starts flowing divided by 2. If you remember the Mohr stress circle, remember that. And then we, at at every line, this is my stress, this is my shear stress uh, coordinate shear stress. So over here at the same radius, the radius is, if you know what is this middle point is the average, you see. So sigma over 2. So that is equal to tau shear stress flow. Then comes some working temperature. If the material being forged is below the half of the melting point or 40% of the melting point, this is cold forging. And if it is above 60% of the melting point, this is hot forging. And you will use different formula, strain rate effect, because it changes very fast. The height changes very fast. Please write down these two formulae. Sigma equals to K times epsilon. And when the temperature, forging temperature is less than half of the melting point. And when the forging temperature is higher than the half of the melting point, mostly like 0.6 of, so then you consider the strain rate. Strain rate is the velocity of the forging force, velocity divided by the instantaneous height. I would say final height, HF, final height. So let's study our forging forces. I think in the early stages, early ages, we used to forge it by hand, but in order to do the hot forging, we used some kind of fuel, maybe wood or burning coal, and then we used to forge it when it is very, very hot into the desired shape. This is an example of the old hammer forge. This is the uh, example of the open and the closed die. This is our open die, and this is our open die. This is a closed die. And when we use the closed die, we still have some material coming inside the gaps, which needs to be cut away once we remove. This is the total part. Look, or the total part, the required part is this one. But this is extra material which we cut after the forging is complete. We usually do the hot forging. This is an example of open die forging. This is our hammer forging force, and this is our platen, the bottom platen, and it reduces the height of the forging force. Some forging material are ring force forging. What is ring forging? Using this ring forging process, you make a ring with a forging force. The guy is very, very small in this case as compared to the big uh, ring forged material. Maybe they are being used in marine vessels where we have big, big engines. Forging force, it reduces the height of the material. In a closed die process, we have the top plate, which has a top die, the bottom plate, which is uh, another part like a sand mold, top part and bottom part, but it's not a mold, it's a forging hammer. But the shape of the hammer is like a die. I think on the right, it is the crankshaft of an engine. It looks like a crankshaft. I- these are important. You will see later down the road that I will start doing the analysis from the center line, but this piece or left piece or the right, I will take a small piece of the forging material, and I will show you when the forging force hit the material from the top and the bottom is a reaction force. Suppose the top is applied force and the bottom is the reaction force, and then it generates some stresses to the right is different than to the left, and the material on the left hand side. You will tell me the material is moving to the left. Agreed? If the material moves to the left on the left side of the center line, then what is the shear force? To the right, force of friction. Force of friction is what is force of friction? Mu times the normal force. Mu times the normal force. Law of flow. And normal force is P. Can I write down like this? Agreed? Because mu times N is the friction force, mu times N, and that it needs to be which is a tau friction. We will do the force balance in the x direction. Forging types are, I mentioned earlier, the coin, small scale, landing gear, large scale, crankshaft, medium scale, turbine shafts, large scale. Forging presses, hold dies, form parts. Hydraulic presses, mechanical presses, and screw presses, hammers, gravity drop, power drop, counter blow, high pressure gas. But the main thing, you see 50,000 tons of forging force. That press is very, very huge. And you see the guy sitting over there, so tiny. Who is being forged? He's trying to push with a forklift. I think there's a forklift here. The machine is bringing the material into the 50,000 ton of press. I think maybe related with the aeroplane landing gear. Very big. Maybe you find a job later down the road in this industry. How to manufacture landing gear of aeroplane. We don't know. You will apply to different manufacturing companies. They will tell you, do you know about casting and forging process? Yes, Professor Salman taught us. We know the formula. Okay, we give you the job. Give us good analysis. Maybe 100K starting salary. Very big Boeing. My friend is working at Boeing company, manufacturing Boeing, and Boeing is selling the whole world planes to the European nations, Asian nations, countries. Very big company. Airbuses. I think you should apply to Boeing after this. Maybe, I'm not sure. But you see, these knowledge skills will open more job opportunities for you after this class. This is more of a hands-on classes, forging forces, different type of dies and the RAM. The final shape determined by the die accuracy and so on. These are not analysis, therefore I'm skipping some of the reading. You will read them at home. Can you read these slides when you are at home or you are busy? You see, energy keeps on increasing, gravity dropped, power drop, high energy rate forming. Forging press parameters, load capacity, strokes per minute, and power output. Hydraulic presses. I think hydraulic presses are the large create forces of very high magnitude, 500 meganewtons. High speed straight side, 2000 kilonewtons. The large force coming from hydraulic presses. hot offsetting machine parameters, strokes per minute power requirement. So what are the forging steps? First, you prepare the slug. Slug is being forged. Okay, that material is being forged. You either saw it or flame cut it or shear it, and the clean slug surfaces, short blast flame. You clean it off, and then you put it into the press. After you prepare the slug and you bring it into the die, open die or the closed die. For hot forging, heat up to and descale the forging, make sure press is hot. Lubricate, we also use the lubricating oil to reduce friction. Friction plays an important role. You will see in the analysis this tau of flow, it is reduced when you have less friction between the hammer surface and the forging first surface. We want to reduce that friction. It reduces lubrication, reduces friction, reduce die wear, thermally insulate part to keep it warm. Then the next step is the forging force. And after we do the forging, we remove the flash, the trim off. I mentioned earlier the extra flash which comes out of the closed die. It needs to be removed either by machining or by cutting. Check the dimension, or if you want to heat treat it. Some microstructure changes, they became more uniformly distributed grains. When they are uniformly distributed, they have more strength. Some forging defects, the bulging out of the material due to the larger friction. Some more forging defects, the die, the rib webs, laps, and so on. And summary. It is just an introduction of the forging process. We will do the analysis next time. Thank you for attending the class today.